Traditional IQ assessments might predict school success, but they fail to capture the vast array of human talents. Today's intelligence tests reduce our mental faculties to a single number, often overlooking abilities like creativity, navigation, or interpersonal skills. This narrow view influences how educators and society judge individuals, potentially limiting opportunities. Challenging this status quo, the theory of multiple intelligences suggests a broader spectrum of intelligences beyond academic metrics, sparking a needed reconsideration of how we assess and celebrate human potential. Learning from diverse cultures. Across the globe, young individuals demonstrate extraordinary skills outside traditional academic pursuits. From a budding sailor mastering star navigation to a youth memorizing sacred texts, these examples exhibit profound intelligence. Such skills underline the inadequacy of conventional intelligence measures in recognizing cultural and contextual knowledge. By observing and understanding these diverse competencies, we can reshape our understanding of intelligence to be more inclusive and adaptable, valuing different cultural insights and life skills that traditional IQ tests tend to overlook. Building a new framework. To truly grasp human intelligence, we must construct a framework that respects diversity in intellectual abilities. This means moving beyond single-dimensional evaluation systems and acknowledging multiple paths to knowledge. Such a framework could better align educational practices with the unique talents and strengths of each individual. It encourages the creation of new teaching methods and learning opportunities that cater to varied intellectual pursuits, fostering environments where different kinds of intelligence are nurtured and allowed to flourish. A historical perspective. Western civilization has long revered intellectual powers, evident from philosophical giants like Socrates and Descartes, who championed reason and knowledge. However, this approach has often overshadowed other virtues, such as feeling, faith, and creativity. Despite historical debates about the nature of intellect, both proponents of singular and multiple mental faculties have shown us that intelligence cannot be neatly boxed. This broader perspective urges us to revisit and expand our definitions, seeing intelligence as a rich tapestry rather than a single thread. Intellectual pluralism in psychology. Psychology has seen an ongoing debate over whether intelligence is a single unified ability or a combination of distinct faculties. While some argue for a general G factor, others promote the idea of diverse, independent mental abilities. Multiple intelligences theory dovetails with the latter, proposing that the mind is a complex ecosystem of interwoven capabilities. By acknowledging this pluralism, we are better positioned to appreciate and cultivate specific intellectual talents, whether they be logical, linguistic, spatial, or kinesthetic. Educational implications. Understanding and identifying diverse intelligences can revolutionize education. By recognizing students' unique intellectual profiles, educators can craft personalized learning experiences that play to their strengths and interests. Early identification of talents allows for the channeling of resources into developing these skills, enhancing educational outcomes. Furthermore, tailored educational strategies can assist those with atypical or uneven intelligence profiles, offering targeted support to help all learners shine. This approach prepares students not only for academic achievement, but also for real-world success. Global perspectives and applications. Encouraging a global dialogue on multiple intelligences can spark innovation in education across cultural boundaries. By exploring how different societies nurture intelligence, we can gather insights for developing more effective teaching methodologies worldwide. With the right framework, emphasizing cross-cultural learning and adaptation, educators and policymakers can create universally applicable practices that respect cultural diversity in learning. This promotes a richer, more adaptable educational landscape that prepares students for a complex, interconnected world. In the late 18th century, Franz Joseph Gall made an intriguing observation. Certain mental traits seemed linked to particular head shapes. This led to phrenology, a belief that skull differences reflect brain function variations. Though ultimately flawed, as brain size doesn't equal intelligence, Gall's ideas laid groundwork for modern neuroscience. Despite its flaws, phrenology gained popularity due to its simple doctrine and support from contemporary scientists. Gall's suggestion of localized brain functions, while not entirely accurate, sparked further exploration, hinting that specific brain areas could control distinct mental capacities, a concept that continues to influence neurological theories today. Early theories on brain and behavior. Theories about the brain's role in behavior date back centuries. Pythagoras, Plato, and Aristotle each had unique ideas about the mind's location and essence. In the 19th century, fresh attempts emerged to correlate specific brain regions with intellectual abilities. The debate between localization of function and broader sensory faculties persisted, with Pierre-Paul Broca's research in the 1860s affirming a link between brain lesions and cognitive impairment. His work, particularly involving language impact from left cortex damage, inspired subsequent studies. While today's science debunks many early misconceptions, it acknowledges the early groundwork laid in linking brain structure to cognitive function. Scientific beginnings of psychology. In the latter half of the 19th century, psychology began to establish itself as a distinct science, notably through the works of Wilhelm Wundt in Germany and William James in America. Diverging from philosophical roots, these pioneers sought to distance psychology from physiology and neurology. As this new discipline explored the laws governing memory, perception, and attention, it remained largely disconnected from empirical brain research. Yet, this era laid the foundation for later studies that sought to understand mental faculties as operating across different contexts, ultimately leading to the development of intelligence tests, which would dominate the psychological landscape in the 20th century. Rise of intelligence testing. Intelligence testing became a cornerstone in psychology with the development of tools to assess human capability quantitatively. Sir Francis Galton pioneered statistical methods to rank intelligence and professional accomplishment. Alfred Binet and Theodore Simon further refined these ideas, creating standardized tests to evaluate children's readiness for school. The enthusiasm for intelligence testing surged as these assessments promised to identify aptitudes and guide educational placement. Yet, over time, scholars recognized limitations such as cultural biases in tests and their predictive power being largely confined to academic success. This recognition has led to ongoing debates about the validity and applications of IQ testing. Debates over IQ and intelligence. The emergence of IQ tests sparked debates, particularly over the concept of a general intelligence, G factor, championed by Charles Spearman. In contrast, L. Thurstone argued for multiple independent mental faculties, suggesting a less unified approach to intelligence. Despite extensive analyses and the use of statistical methods to support both views, neither perspective gained definitive dominance due to their mathematical underpinning, making empirical resolution elusive. With scholars noting the test's cultural biases and limited real-world applicability, the debates highlight that intelligence is multifaceted, and the philosophical framing still influences how we assess cognitive competencies today. Piaget's cognitive development theory. Jean Piaget introduced a revolutionary perspective on intelligence, emphasizing cognitive development through distinct stages. Rather than focusing solely on correct answers, he examined the reasoning children utilize in problem solving. Piaget's model illustrated stages from sensorimotor in infancy to formal operations in adolescence, highlighting structured cognitive growth. Despite its influence, Piaget's theory faced criticisms for its rigidity and applicability, mainly to Western contexts. Researchers found cognitive abilities develop more fluidly than his stages suggest, and his focus largely ignored creativity and non-scientific forms of intelligence. Nonetheless, Piaget's emphasis on development and reasoning continues to shape educational approaches. Emergence of information processing psychology. By the latter 20th century, the information processing perspective emerged, likening human cognition to computer operations. This approach focused on meticulously detailing how individuals process information, solve problems, and make decisions. Emphasizing real-time cognitive processes, it diverged from Piaget's stages, aiming to simulate human thought on computers. While offering a dynamic view of cognitive functioning, the approach also faced criticism. It often remained disconnected from biological realities and lacked a coherent theory unifying varied problem-solving strategies. Despite these issues, it revived interest in cognitive mechanisms and redefined psychological investigations into how humans process information. Symbol systems and cognitive diversity. In response to the limitations of previous theories, an alternative viewpoint emerged focusing on human symbolic capacities. Scholars like Ernst Cassirer and Suzanne Langer emphasized the role of symbolic systems, language, music, art, in shaping cognition. This perspective proposed exploring diverse cognitive domains beyond conventional logical mathematical models, encompassing different cultures and unique skills. Recognizing that cognitive development could vary widely across individuals and cultural contexts, this approach challenges the notion of a singular developmental path. By examining the symbolic use within specific domains, it seeks to broaden the understanding of human intelligence, emphasizing creativity and cultural diversity in cognitive studies. Understanding intelligence through prodigies. The study of prodigies, individuals with exceptional abilities in specific domains, offers insights into cognitive development. Their remarkable skills highlight how intelligence can manifest uniquely within different symbolic systems, differing significantly from traditional development models. Prodigies challenge Piaget's uniformity theory, showcasing unusual patterns of growth aided by inherent talents, cultural factors, and systematic nurturing. This exploration underscores the importance of environmental influences and cultural contexts in intellectual achievement, emphasizing that intelligence is not solely an individual trait, but a complex interplay between innate capabilities and societal frameworks, enriching the narrative of human intellectual diversity and potential. The role of culture in cognitive development. Cultural contexts play a pivotal role in shaping intelligence, as they define which symbolic domains are valued and developed. Educational psychologist David Feldman posits that while some cognitive domains are universal, others are culture-specific or uniquely individual. The proficiency within these domains is largely conditioned by cultural practices and societal expectations. As individuals navigate through these environments, their intelligence is molded, highlighting the dynamic interaction between biology, personal inclination, and cultural learning. This perspective urges a broader understanding of intelligence, advocating for an inclusive view that respects diverse cultural contributions to the development of human intellect. Human development showcases remarkable plasticity, especially in early life stages. Contrary to the belief that development is strictly preordained, there's significant flexibility that allows our intellectual capacities to be shaped by various interventions. This biological elasticity implies that proper educational practices, applied at critical periods, can enhance intelligence. This notion challenges us to explore which types and timings of interventions could optimally unlock intellectual potential. Essentially, while genetics lay down the blueprint, environmental interactions sculpt these capabilities, granting humans a unique capacity for growth and adaptability. Identity of human intellectual capacities. Human intelligence isn't a single entity, but a bouquet of specialized capacities. Some intellectual functions appear to be general purpose, while others are distinctly specialized. This diversity reflects both inherited predispositions and environmental influences. As our brains host varied neural systems, they support specific intellectual operations, like language and spatial reasoning. Researchers emphasize how different brain regions align with particular cognitive roles, illustrating how human intellect is not only a product of our genetic makeup, but also our experiences. This interaction between fixed biological traits and malleable environmental influences shapes the full spectrum of human intelligence. Lessons from genetics on intelligence. The field of genetics offers intriguing but complex insights into intelligence. Since the discovery of DNA's structure, scientists have explored its influence on our mental capabilities. However, while genetic studies have explained simple traits in basic organisms, human intelligence remains enigmatic. Complex abilities like language and musical talent involve intricate gene interactions, making them difficult to trace. Twin studies provide some guidance, showing hereditary tendencies, but conclusions on intelligence heritability vary widely. This suggests that while our genetic code lays the ground rules, environmental factors significantly mold our intellectual profiles. Neurobiology's role in understanding intelligence. Neurobiology shines a light on intelligence by illustrating how the brain's flexible architecture supports cognitive functions. The nervous system exhibits both canalization and plasticity, indicating a mix of strict genetic programming and adaptive potential. Notably, certain life periods offer heightened malleability, crucial for fostering intellectual growth. These plastic phases, bolstered by studies on visual systems and animal behavior, reveal how sensory experiences shape cognitive abilities. Moreover, neurobiological research underscores how enriched environments enhance learning, aligning with educational approaches that nurture human intellect through stimulating experiences. Canalization versus plasticity in development. Canalization and plasticity represent two sides of the developmental coin. Canalization refers to the genetically guided paths our development typically follows, ensuring species-specific traits. However, plasticity counterbalances this rigidity, allowing organisms to adjust to environmental changes and overcome early injuries. This dynamic is evident as organisms, including humans, navigate their developmental journeys. While early injuries may reroute traditional growth paths to new, functional avenues, plasticity diminishes with age. Understanding this balance helps us appreciate how genetic predispositions and environmental factors jointly fine-tune our cognitive growth. Principles of brain plasticity in early life. Brain plasticity is remarkably pronounced in early life, granting young organisms robust adaptability. This adaptability is exemplified by phenomena like rapid environmental learning and recovery from early brain injuries. During critical development periods, the brain's architecture remains uncommitted to specific functions, providing a window for diverse skill acquisition. For instance, children can recover language abilities even after significant brain injuries if interventions occur early. However, this plasticity wanes over time, highlighting the importance of timely exposure to enriching environments to optimize intellectual development. The influence of early experiences. Early life experiences play a pivotal role in intellectual development. Studies show that environments rich in stimuli lead to greater cognitive achievements and even structural brain enhancements. For instance, animals raised in enriched settings display superior learning capabilities and more complex cerebral features than those in deprived conditions. This underscores the significance of an engaging atmosphere for fostering intelligence. While enriched environments bolster cognitive growth, the absence of stimulus can lead to developmental delays. Thus, the early experiences we provide can significantly mold intellectual capacities throughout life. Insights from animal learning studies. Studies on animals, like songbirds and mollusks, offer parallels to human learning processes. Research on birds reveals that song mastery involves both environmental exposure and inherent predispositions, akin to humans learning language through interaction and practice. Likewise, investigations into simple organisms show how synaptic alterations underpin basic learning forms. These studies highlight common biological learning mechanisms across species. Through meticulous dissection of such processes, researchers aim to draw connections between these foundational behaviors and more complex human cognitive functions, offering a window into the evolutionary roots of intelligence. Brain architecture and cognitive functions. The brain's organization is crucial to understanding cognitive functions. It consists of specialized regions with distinct roles, emphasizing how different areas govern various intellectual tasks. This is evident through observations in language processing, where Broca's and Wernicke's areas manage speech production and comprehension, respectively. Such specialization suggests that our brain has evolved to handle complex tasks through a network of dedicated regions. These findings reveal potential biological bases for multiple intelligences, affirming the notion that human cognition is a concert of specific, interdependent functions crafted by nature. Different perspectives on brain organization. Views on brain organization have evolved alongside scientific advances. The debate oscillates between seeing the brain as a collection of distinct units and a unified processing machine. While localization theories emphasize specialized brain areas for different functions, holistic perspectives consider the brain's equipotentiality. Recent insights support a middle ground. Specific regions are integral for certain tasks, but cooperation among brain areas is crucial. This synthesizes the notion that while the brain exhibits specialization, its true strength lies in the interplay of its regions, reflecting a sophisticated orchestration of intelligence. Human intelligence is a multidimensional concept, not confined to a single ability or trait. This perspective advocates for acknowledging various intellectual strengths, each developing uniquely over time. Advances in psychology and neurobiology suggest that these intelligences correspond to distinct brain regions. However, listing all possible intelligences is elusive. The goal is not to finalize a master list, but to enhance understanding and communication about intellectual capabilities, assisting educators and researchers in their fields. Redefining intelligence prerequisites. Intelligence should encompass problem-solving skills and the capability to create and identify new problems, fostering knowledge acquisition. These prerequisites ensure that such abilities are culturally valuable, although their importance may vary globally. While some skills, like facial recognition, have specific neural representation, they may not be highly regarded across cultures. The emphasis is on identifying intellectual strengths that are meaningful and have practical applications within different cultural contexts. Criteria for identifying intelligences. Selecting distinct intelligences involves evaluating multiple criteria. Potential isolation through brain damage, evidence of prodigious talents, core operations, and unique developmental histories are significant indicators. Additionally, considerations of evolutionary plausibility, support from experimental psychology, and susceptibility to symbol systems also play vital roles. The task is as much an art as a science, and the goal is to outline a framework highlighting core intellectual capacities. Insights from brain damage. Brain injuries offer profound insights into the autonomous nature of different intelligences. Specific lesions can impact particular abilities while sparing others, helping to differentiate distinct cognitive processes. These cases reveal the modular organization of our minds, where certain abilities can be independently affected, providing compelling evidence for the existence of separate intelligences. The role of exceptional individuals. Prodigies and individuals with uneven intellectual profiles, such as idiot savants, spotlight distinct intelligences. A prodigy's advanced abilities in one area contrast with their average skills elsewhere, hinting at isolated developmental processes. Similarly, savants exhibit remarkable talents despite other limitations. These cases underscore the autonomy and genetic basis of certain intellectual strengths, adding weight to the multiple intelligences theory. Developmental and evolutionary aspects. Intelligences have identifiable developmental paths, from novice stages to expert performance levels. These paths include critical periods and milestones impactful for education. On an evolutionary scale, intelligences carry antecedents evident in species-wide competencies. Tracing these practices back through time reveals how they evolved, not in isolation, but by integrating various capabilities, laying a broader framework for understanding human cognition. Psychometric and psychological influence. Psychological experiments and psychometric tests furnish insights into how various intelligences function. While traditional IQ tests have limitations, they still offer valuable clues about distinct cognitive abilities. High correlations within tasks of the same intelligence and low correlations with others support this theory. Nonetheless, each intelligence's unique expression can complicate straightforward testing, challenging us to refine our understanding beyond standardized assessments. The importance of symbol systems. Symbol systems, such as language and mathematics, play crucial roles in manifesting human intelligence. An intelligence's utility is enhanced when it corresponds to a cultural symbol system. This relationship underscores how symbol systems likely evolved to leverage cognitive capacities. While some intelligences may operate without distinct symbol systems, embodying them within cultural symbols enhances their practical relevance and application. Navigating misconceptions. Despite popular perceptions, intelligences transcend sensory systems and cannot be strictly equated to measures of sensory input. They are broader than simple computational mechanisms, but narrower than overarching abilities. They work according to unique rules. Thus, comparisons must respect their distinct nature. Intelligences can serve various purposes, and not always benevolent ones. Understanding them as independent potentials rather than actions clarifies their role in human capability. Linguistic intelligence encompasses a deep sensitivity to the nuances of language, a skill that poets and writers hone through careful word selection and syntax arrangement. It goes beyond simple vocabulary knowledge, involving an intricate understanding of phonology, semantics, and pragmatics. The art of language lies in the ability to use words to evoke imagery and emotion, a mastery seen in the works of renowned poets. Linguistic intelligence is not just about the words themselves, but how they are woven together to create meaning and evoke a response from the reader or listener. Poetry, a model of linguistic craftsmanship. The world of poetry exemplifies linguistic intelligence. Poets like T.S. Eliot and Robert Graves demonstrate the precision and care involved in crafting their verses. They meticulously weigh alternative wordings to achieve the perfect balance of sound and meaning. This process requires not only a keen ear for the musicality of language, but also an understanding of syntax and semantics. Through poetry, linguistic intelligence manifests as the capability to communicate complex emotions and images through minimalistic yet powerful language. Mastery of language and literary giants. Literary greats, such as Jean-Paul Sartre, reveal the relentless drive to refine their linguistic skills. From a young age, Sartre exhibited a precocious ability to mimic adult speech, eventually evolving into a prolific writer. His journey underscores the importance of practice in developing linguistic intelligence. Writers emphasize the necessity of daily writing as it strengthens their linguistic muscle. Through continuous practice, writers like Sartre cultivate a personal style that allows them to express complex ideas succinctly and effectively. The meticulous art of revision. Revision is a crucial aspect of linguistic intelligence, enabling the refinement of thought and expression. T.S. Eliot's meticulous revision process involved testing numerous word combinations before settling on the most accurate and evocative phrasing. This attention to detail ensures consistency and clarity in conveying the poet's vision. Similarly, Stephen Spender illustrates the iterative nature of crafting poetry, where layers of revision lead to the final piece that aligns with the original creative impulse. Such dedication highlights the cognitive effort involved in linguistic craftsmanship. Semantics and syntax, foundations of meaning. Understanding the interplay of semantics and syntax is fundamental to linguistic intelligence. Poets and writers must navigate these elements to maintain consistency and coherence in their work. Semantics involves the connotations and meanings of words, while syntax dictates sentence structure and grammatical rules. Linguistic masters use these components to balance their work's thematic and emotional impacts. By mastering the subtleties of semantics and syntax, they achieve a level of communication that resonates deeply with their audience. Phonology and auditory sensitivity. Phonology, the study of sound patterns, is another facet of linguistic intelligence. Poets, in particular, leverage auditory sensitivity to create rhythm and musicality in their work. This aspect requires an acute awareness of sound relationships and the ability to manipulate these elements to enhance the reader's or listener's experience. The auditory dimension of language contributes significantly to its emotional and aesthetic impact, making phonological skills a crucial component of a poet's linguistic repertoire. The pragmatic functions of language. Beyond semantics and syntax, pragmatic understanding is vital for effective communication. This involves recognizing the different functions of language, from persuasion to narration. Linguistic intelligence includes the capacity to use language strategically based on context, audience, and intention. This skill is not limited to poets. It is crucial for politicians, educators, and anyone who relies on effective communication to achieve specific goals. Pragmatic language use involves a sophisticated awareness of language's power to influence thought and action. Language, a tool, and its cultural variations. Language serves various functions across cultures, often reflecting societal values and needs. In some cultures, oratory and memorization were historically prized, while others emphasized literacy and written communication. The cultural context shapes how linguistic intelligence is developed and valued, making it a rich and multifaceted skill. As societies evolve, so do the roles and uses of language, demonstrating its adaptability and fundamental importance in human interaction and cultural continuity. Neuroscience insights on language processing. The human brain's capacity for language involves specialized regions, predominantly in the left hemisphere, dedicated to different linguistic functions. Understanding how these areas interact provides insight into language processing and the neural basis of linguistic intelligence. Aphasia studies reveal how brain injuries can isolate specific language functions, underscoring the complexity and specialization of language in the brain. This neuroscience perspective affirms the distinct nature of linguistic intelligence as a unique human capability. The evolutionary development of language. Language evolution is a testament to human cognitive advancement. The development of the vocal tract and neural mechanisms capable of rapid speech distinguished humans from other species. While hypotheses about language evolution vary, it is clear that linguistic competence has ancient roots and has enormously impacted human culture and society. The sophistication of language reflects a culmination of evolutionary processes, enabling complex communication and fostering cultural and intellectual growth. Musical talent often emerges very early in childhood, often before other forms of intelligence are apparent. This early development can be due to varied factors such as exposure to music in the environment, innate abilities, or even specialized programs like the Suzuki method. Children may exhibit prodigious abilities to play instruments, recall complex compositions after a single hearing, or even create original music. These early displays of talent can arise from different backgrounds. Some children grow in music-filled environments. Others might have limited communication skills, but possess an isolated, strong musical intelligence. Yet, possessing musical talent early does not ensure future success. It needs nurturing within an encouraging environment. The journey from musical prodigy to adult composer. While many gifted children show remarkable early musical talent, only some continue to develop into accomplished adult musicians. The path to becoming a composer usually involves intense dedication and education. Many composers begin as performers, developing skills that they later build upon to create original works. The ability to compose involves not just technical mastery, but also creative imagination, as composers transform fleeting ideas into structured musical pieces. Renowned educators and composers, like Aaron Copland and Roger Sessions, emphasize the naturalness of the composition process, which often involves reshaping basic musical ideas that come as a gift from heaven. Core elements of musical intelligence. Musical intelligence comprises several elements, including pitch, rhythm, and timbre, which together form the foundation of musical expression. Different cultures might emphasize these elements differently, such as the nuanced use of pitch in Oriental music or complex rhythmic patterns in African music. While music relies heavily on auditory capabilities, its emotional and affective aspects significantly impact how we perceive and engage with it. Music evokes emotions from joy to melancholy, and its power to affect our feelings is both profound and mysterious. Researchers are keenly interested in how these core components of music intertwine with affective and cognitive processes. Psychological perspectives on music perception. The study of music perception uncovers how individuals process musical sounds, from basic tones to complex compositions. Researchers have used both bottom-up approaches focusing on individual elements and top-down approaches concentrating on entire musical pieces to understand musical perception. Recent research often takes a middle ground approach, studying entities large enough to resemble real music but manageable enough for systematic analysis. Such studies reveal that most people can appreciate musical structure and comprehend the relationships within musical keys and rhythms, indicating that musical comprehension is an intricate blend of learned skills and natural perception. Developmental stages in musical competence. Musical competence evolves through distinct developmental stages, beginning as early as infancy when children start to mimic and produce musical sounds. Initially, children's musical expressions are spontaneous, but they gradually incorporate the musical structures prevalent in their surroundings. This early engagement lays the foundation for more advanced musical skills acquired through formal education or cultural practices. The development can vary greatly across different cultures, where societies like the Anning prioritize comprehensive early musical education, leading to proficient singing and playing skills by the time children reach school age. Influence of culture and genetics on musical ability. The confluence of genetics and cultural influences shapes musical ability. While some families like the Bachs and Mozarts showcase generational musical talent, often these abilities emerge regardless of familial musical history. Talented individuals can arise in any environment, demonstrating innate musical capabilities like precise pitch recognition or melody recall. Cultural factors also play a significant role. Societies that emphasize musical proficiency, like Hungary or Japan, often see widespread musical skill development amongst children. Such evidence suggests that while genetic predispositions might exist, cultural encouragement can significantly enhance musical skill acquisition. Neurological aspects of musical intelligence. Music engages the brain in complex ways distinct from language, involving different neural pathways. Research indicates that while most musical processing occurs in the right hemisphere, trained musicians increasingly engage the left hemisphere, indicating that expertise can alter brain activity. Certain conditions, such as amusia, showcase the localization of musical abilities, often affecting the right hemisphere. The neural representation of music varies considerably among individuals, possibly due to different musical exposures and engagements. Yet, these variations reinforce music's autonomy as an intellectual pursuit, possessing unique brain processing systems. Unusual musical talents and anomalies. Unusual instances of musical talent often highlight the independence of musical intelligence. Many autistic individuals exhibit exceptional musical abilities even amid other cognitive challenges. Some can memorize and perform music with high precision, demonstrating profound musical comprehension amidst developmental limitations. Exceptional cases like savants exhibit capabilities that seem almost isolated within their overall abilities, pointing to a fascinating preservation of musical talent even when other cognitive areas are impaired. These examples provide insight into the unique and isolated nature of musical intelligence, suggesting it operates independently from other cognitive faculties. Music's integration with other intelligences. Music maintains intriguing connections with other intellectual spheres, often weaving into cultural expressions. It is linked with body movement and gestures, suggesting a precursor to dance and performance arts and fostering spatial awareness and skill through its structures. While some speculate that music shares parallels with mathematical thinking in terms of patterns and structures, its primary engagement remains deeply expressive, focusing on emotional conveyance rather than mathematical precision. This interconnectedness challenges scientists to understand music's role within the broader scope of human cognition and experience. The persistent mystery of music's human significance. Despite its apparent lack of survival function, music remains central to human life, prompting deep emotion and cultural expression. Its origins may be intertwined with language development, but music has evolved into an independent force. Musicologists speculate that understanding music could unlock broader insights into human cognition, given its interaction with feelings and various cultural practices. Its autonomous nature, underscored by neurological studies and cultural diversity in expression, continuously captivates researchers striving to comprehend the multifaceted role music plays in our lives. Logical mathematical intelligence encompasses our ability to reason, abstract, and navigate numbers, crucial for solving problems and understanding the world. Jean Piaget's landmark research illuminated how this intelligence evolves from a young age. He illustrated that foundational logical mathematical knowledge stems from our interactions with the physical environment, beginning with infants who learn through exploratory actions. Over time, these interactions morph into higher-level abstract thinking, forming the basis for more complex cognitive functions like problem-solving and logical reasoning. Piaget's developmental stages highlight key milestones such as object permanence and classification, which eventually give rise to the ability to manipulate abstract symbols and concepts. Piaget's developmental milestones in cognition. Piaget mapped out distinct stages in children's cognitive development, emphasizing how logical necessity becomes an integral part of reasoning as children mature. From sensory-motor actions, children advance to concrete operations, where they grasp quantities and numbers. The final leap occurs in adolescence, when formal operational thinking emerges, allowing abstract thought manipulation. Although Piaget's framework is foundational, later studies suggest these stages might be more fluid than originally thought. Children can show advanced reasoning at earlier stages or struggle with abstract logic despite age. This insight underscores the complexity of cognitive development, intertwined with individual and cultural variations. The abstract world of mathematicians. Mathematicians thrive in the abstract, wielding logic and numbers as they unravel complex patterns. Esteemed figures like Euler exemplify this craft, demonstrating how logical mathematical prowess manifests as an ability to handle intricate reasoning chains. From an early age, mathematicians often showcase a distinct talent for pattern recognition and abstraction, reaching their intellectual zenith before midlife. Recognized for their structured thought processes, they can construct enduring mathematical concepts and frameworks that transcend time. The mathematician's pursuit, driven by a passion for timeless patterns, highlights the nuances and distinctive nature of this intelligence. Scientific thought, a quest for understanding. While closely linked to mathematical reasoning, scientific thinking diverges in its pursuit of explaining physical reality. Scientists like Einstein and Newton exemplify this approach, driven by a quest to unravel the universe's mysteries. They strive for theories aligned with empirical evidence, favoring elegant, unified explanations of natural phenomena. However, unlike mathematicians who revel in abstractions, scientists prioritize concrete models reflecting observed reality. Despite their different goals, both disciplines cherish rigorous logic and systematic inquiry. This distinction highlights the diverse motivations and methodologies underpinning scientific versus mathematical advances. Cultural variations in logical mathematical cognition. Logical mathematical cognition manifests differently across cultures, influenced by context and societal values. While Western cultures emphasize abstract thinking in education, other societies might prioritize functional cognitive skills for survival. Pre-literate cultures, for example, often demonstrate keen estimation skills essential for daily tasks. Moreover, societal interactions, including traditional games and strategic activities, foster logical thinking without formal education. These cultural forms of intelligence illustrate how logical mathematical skills adapt to varied environmental demands. However, despite cultural differences, basic skills like calculation and classification remain universal cognitive tools. The role of logic in belief systems. Despite humans' intrinsic logical capacity, many maintain inconsistent beliefs, yet these don't typically disrupt daily decisions. Logic plays a paradoxical role, underpinning reasoning while enduring alongside belief systems, defying it. This phenomenon shows logical mathematical intelligence's limits. While powerful for problem-solving, it doesn't dictate all thought realms. Cultural and environmental influences shape belief systems that may seem illogical. In Western societies, education emphasizes logic and abstract reasoning, yet everyday beliefs often diverge from pure logic, underscoring the nuanced relationship between cognition and cultural practices. Reevaluating science, insights from Kuhn. The nature of scientific inquiry has evolved since Thomas Kuhn's critiques on its linear progression. Kuhn proposed that science doesn't simply advance toward an ultimate truth. Instead, paradigm shifts reveal how scientific understanding morphs over time, each providing insight while obscuring other aspects. This nonlinear progression underscores the transient nature of scientific consensus, where yesterday's truths may shift. As each scientific era brings its worldview, skill sets relevant in one may become obsolete in another. This dynamism challenges the idea of a unified scientific understanding across fields. Technology, shaping scientific and mathematical futures. Rapid technological advances redefine the landscape of both science and mathematics. As computers and other technological innovations become integral, the distinction between human and computational contributions blurs. This shift suggests a redefinition of problems and approaches within disciplines, challenging traditional frameworks. As technology influences logical mathematical pursuits, fields evolve, propelling new methods, innovations, and partnerships. The growing intersection of technology highlights the potential for advancements that once seemed distant, illustrating how logical mathematical intelligence must adapt alongside to remain relevant. Logical mathematical intelligence among multiple intelligences. Despite its prominence, logical mathematical intelligence is just one facet of human intellect, not inherently superior to others. This form of intelligence excels in specific contexts, like solving abstract puzzles or conducting scientific experiments, making it appear central in educational and professional settings. However, its relevance varies culturally and contextually, challenging the notion of its supremacy. Logical mathematical intelligence often intertwines with other intelligences, such as spatial reasoning, although connections between disciplines like music and mathematics hint at shared cognitive frameworks. Understanding these links reveals a richer spectrum of human cognitive capabilities. Interdisciplinary connections, math, logic, and creativity. Individuals inclined toward logical mathematical intelligence often find intersections with creative fields, influenced by their inherent systematized thinking. While mathematicians may gravitate to music or art, these interests aren't always reciprocated by artists. This crossover showcases a deeper cognitive connection between order, pattern recognition, and creativity. Such interdisciplinary links highlight how diverse intelligences enrich each other, offering a broader perspective on human capability. Understanding these overlaps suggests that cognitive skills are interconnected, each discipline shedding light on the potential secrets of the universe. Spatial intelligence is the ability to perceive the visual world accurately, transform and manipulate perceptions, and recreate aspects of one's visual experiences. This capacity includes recognizing shapes from different angles, imagining movements, and solving complex spatial problems. Although related, these abilities are distinct and can develop independently. Spatial intelligence is crucial in fields requiring visualization and transformation skills, such as engineering and the arts. While some people naturally excel, others may find spatial tasks challenging, highlighting the variations in how this intelligence develops and manifests in individuals. Tools and tests of spatial skills. Testing spatial intelligence often involves tasks where individuals must identify shapes, understand rotations, and manipulate visual information. Famous tests, like those developed by Roger Shepard, require subjects to visualize 2- and 3-dimensional forms from different perspectives. These tests reveal the mental gymnastics involved in spatial reasoning, where subjects mentally rotate objects to determine congruence with target shapes. Spatial tasks can also be verbal, challenging individuals to envision transformations without visual aids. These exercises demonstrate the brain's remarkable ability to construct and manipulate mental imagery, a skill fundamental to effective spatial reasoning. Verbal and mental manipulations. Spatial problems extend beyond visual imagery to encompass verbal and abstract reasoning. Puzzles that require folding a paper in specific ways or predicting movements based on descriptions use spatial logic. Such tasks demand a synthesis of visual and verbal skills, demonstrating how spatial intelligence intersects with logical mathematical thinking. Some individuals solve these puzzles verbally, a testament to the brain's capacity to process spatial challenges through diverse methods. This multifaceted approach to spatial problems underscores its role as a versatile and critical component of intelligence, applicable in numerous problem-solving contexts. Spatial intelligence and human development. From childhood to adulthood, spatial intelligence unfolds through interaction with the environment. Children begin with sensory-motor understanding and gradually progress to manipulating mental images, aided by experiences. Jean Piaget's studies highlighted that spatial understanding matures alongside logical thinking. As children grow, they display a keen ability to form mental images and appreciate differing perspectives, eventually mastering abstract spatial reasoning in adolescence. This developmental journey suggests that while spatial intelligence is innate, it benefits immensely from experiences, education, and practice, blending innate potential with learned skills. The brain and spatial functions. Spatial intelligence has robust neural underpinnings, primarily involving the right hemisphere of the brain. Damage to this area often results in deficits in spatial reasoning, revealing its critical role. Studies on stroke victims and those with brain injuries have shown limitations in spatial perception, memory, and imagery. These explorations suggest that particular brain regions handle the intricacies of spatial thought, confirming the right hemisphere's prominence in managing and processing spatial tasks. Neuropsychological research highlights that spatial intelligence draws from both simple sensory input and complex cognitive processes. Spatial skills in diverse cultures. Spatial intelligence is celebrated across cultures, each showcasing unique applications. For instance, the Puluwat navigators of the Caroline Islands exemplify exceptional spatial skills through their star-based navigation techniques. Similarly, the Eskimos' ability to navigate featureless terrains highlights culturally honed spatial abilities. These culturally specific skills show that while methods may vary, the core of spatial intelligence is universal. By observing these practices, we learn how different societies harness spatial reasoning to interact with and dominate their environments, reinforcing the adaptability and utility of spatial intelligence. Spatial intelligence in the arts. In the arts, spatial intelligence plays a pivotal role, especially in painting and sculpture. Artists channel their acute spatial perceptions into creating works that capture the essence of their subjects. Masters like Van Gogh and Le Corbusier exemplified this skill by translating complex forms and colors into coherent artistic expressions. Their work illustrates the blend of meticulous observation and creative synthesis inherent in the visual arts. This realm of spatial intelligence allows artists to push boundaries, inviting viewers to experience the world anew through their vivid interpretations and designs. Spatial abilities and disabilities. Blind individuals challenge the notion that spatial intelligence requires sight. Remarkably, they often demonstrate strong spatial abilities, relying on touch to perceive and interpret space. Research shows that they can create and manipulate spatial representations despite visual limitations. The blind community's capacity to convert tactile experiences into spatial understanding highlights the adaptability of spatial intelligence. Additionally, conditions like Turner's syndrome reveal specific spatial deficits, offering insights into how different disabilities can affect spatial reasoning. These variations deepen our understanding of the diverse manifestations of spatial intelligence. Exceptional spatial talent. Certain individuals exhibit extraordinary spatial abilities, whether in everyday life or under unique circumstances. Renowned figures like Nikola Tesla demonstrated exceptional mental visualization, constructing complex devices in their minds. Similarly, idiot savants and autistic prodigies like Nadia astonish with their prodigious spatial talents. These stories illustrate the wide spectrum of spatial intelligence, from superlative visualization skills to unique cognitive profiles. Such anomalous examples expand our understanding of spatial intelligence, emphasizing its capacity to manifest remarkably in those whose skills differ from the broader population. The lifelong journey of spatial skills. Throughout life, spatial intelligence persists as a vital cognitive ability. While some aspects may decline with age, many artists and scientists retain or even enhance their spatial skills into later years. This phenomenon suggests that spatial intelligence, rooted in concrete experiences, possesses enduring qualities that transcend the aging process. This longevity underscores its importance in maintaining cognitive function and adapting to life's challenges. For cultures and individuals alike, spatial intelligence remains an essential tool for navigating both the physical and mental landscapes of the world. Bodily-Kinesthetic Intelligence is showcased in the performances of mime artists like Marcel Marceau, who create vivid scenes using only their bodies. This form of intelligence enables individuals to convey complex narratives and emotions without the need for language or props. It demonstrates an ability to control physical movement and manipulate the perception of objects and actions in a way that captivates audiences. Mimes use exaggerated gestures and facial expressions to draw attention to details, making the invisible visible. The skills required for mime performance reflect a deep understanding of bodily mechanics and the capacity to create believable illusions, engaging viewers on both a physical and emotional level. Bodily intelligence defined. Bodily kinesthetic intelligence involves the ability to use the body purposefully and precisely. This can range from expressive activities, such as dance, to more practical tasks like crafting or athletics. It's about creating and manipulating objects and spaces with skill, whether through delicate hand movements or more expansive bodily motions. This intelligence underpins physical activities, allowing individuals to excel in domains that require fine motor skills or gross motor activities. It's integral not just for performers like dancers and athletes, but also for inventors and artisans who manipulate physical objects to achieve functional or aesthetic goals. The historical perspective. The significance of bodily intelligence is rooted in ancient history. The Greeks, for instance, idealized the human body, aspiring for harmony between physical grace and mental agility. This form of intelligence was crucial in developing skills necessary for survival, such as hunting and tool-making. Such innate physical prowess has evolved into various cultural expressions, from the precision of martial arts to the fluidity of modern dance. Historically, bodily intelligence was not only a means of physical accomplishment, but also a pathway to cultural and personal expression. This was evident in ancient athletics and artistic performances, where skillful physical expression played a pivotal role in societal activities. Body and mind breaking barriers. In many cultures, there's been a long-standing separation between mental and physical activities, often valuing intellectual pursuits over bodily ones. However, recent insights suggest a strong connection between bodily movements and cognitive processes. Skilled physical performance, like that seen in sports or performing arts, involves a complex interplay of signals from the environment and internal feedback mechanisms, integrating perception and action seamlessly. This seamless integration defies the traditional divide, emphasizing that skillful use of the body is a form of intelligent thinking. Cognitive scientists now see parallels between problem-solving and physical activities, challenging us to appreciate the interconnectedness of mind and body. Evolution of physical skill. The evolution of bodily intelligence can be traced through the gradual sophistication of tool use among early humans. From basic stone tools used by Homo habilis to the complex implements of Cro-Magnon man, the development of bodily intelligence was crucial for survival and cultural advancement. The ability to manipulate tools skillfully not only improved hunting and gathering, but also led to developments in art and symbolic thought, as seen in Paleolithic cave paintings. This evolutionary trajectory highlights the interplay between physical dexterity and cognitive growth, underscoring bodily intelligence as a driver of human progress. Developing bodily intelligence. The development of bodily intelligence begins in infancy with basic reflexes and evolves as individuals engage with their environment. As children grow, they refine their motor skills through play and interaction with objects, gradually integrating these abilities into more complex behaviors. This development follows a sequence of mastery, from simple actions to elaborate skill sets involving cognitive operations. Skills acquired through physical interaction can later translate into abstract thought processes, suggesting that bodily intelligence acts as a foundation for other forms of intelligence, facilitating learning and adaptation in various contexts. Dance, the pinnacle of bodily expression. Dance exemplifies bodily intelligence by combining physical movements with cultural expression. It encompasses a wide range of styles and functions across different societies, from the ritualistic dances of indigenous cultures to the artistic performances in contemporary theaters. Dancers use their bodies to communicate emotions, tell stories, and reflect societal values, demonstrating their ability to execute intricate movements with precision and emotion. Dance is not merely physical, it requires a nuanced understanding of rhythm, space, and audience engagement, embodying both technical skill and expressive power. Acting, the bodily craft. Actors draw on bodily intelligence to bring characters and narratives to life. This involves a deep understanding of body language, physical presence, and emotional expression. Aspiring actors learn techniques to control their bodies, whether through dance, mime, or method acting, to convincingly portray a character's inner world. The ability to imitate and recreate scenes vividly relies on acute bodily awareness and interpersonal intelligence, enabling actors to resonate with audiences. While some focus on internal emotion, others emphasize outward bodily control, showcasing diverse approaches to harnessing bodily intelligence in performance. Athletics, the art of precision. Athletes epitomize bodily intelligence through their mastery of movement, timing, and coordination. Each sport demands specific physical skills, whether it's the speed and agility of a sprinter or the precision of a golfer. Beyond physical prowess, athletes utilize strategy, interpersonal understanding, and emotional resilience to excel. The sensations of movement and body awareness play critical roles in achieving performance excellence. Kinesthetic intelligence is seen in the intuitive ability to make split-second decisions and execute complex physical actions fluidly, highlighting the interplay between physical skill and mental acuity. Creative bodily use. Inventors and artisans demonstrate bodily intelligence through their ability to transform ideas into tangible objects. This requires a combination of manual dexterity, spatial awareness, and cognitive planning. Inventors manipulate materials creatively, using tools to develop functional and sometimes novel solutions to problems. This process involves not just physical skills, but also logical reasoning and sometimes a touch of artistry. Understanding how to manipulate objects effectively points to a blend of bodily kinesthetic and other forms of intelligence, showing that creation and innovation are deeply rooted in physical engagement and cognitive foresight. Personal intelligence is a fascinating domain that focuses on understanding oneself and others. G. Stanley Hall's invitation to Sigmund Freud sets the stage for exploring this world, highlighting Freud's focus on self-knowledge and life's challenges, compared with William James's emphasis on relationships and community. Personal intelligence divides into intrapersonal, which is grasping one's emotions, and interpersonal, which involves understanding others. Both are crucial for personal and social interactions and are shaped by cultural symbols and meanings, making them varied across societies. This diversity begs the question of how personal intelligence fits within other established intelligences. Freud and James, divergent philosophies. While Freud and James hailed from different philosophical backgrounds, they shared a belief in the importance of the individual self. Freud focused on self-exploration, insisting that understanding one's internal world was crucial to personal development. On the other hand, James placed more emphasis on the social fabric, underscoring the significance of community and relationships in shaping the self. Despite these differences, both believed that personal intelligence, ranging from managing personal emotions to navigating complex social roles, was key to human experience. Their unique perspectives underscore the multifaceted nature of personal intelligence. The dual nature of personal intelligences. Personal intelligence consists of two main components: intrapersonal and interpersonal intelligence. Intrapersonal intelligence involves a deep understanding of personal emotions, motives, and desires, ranging from simple reactions to complex feelings like empathy and guilt. This form of intelligence is important for self-awareness and personal growth. On the flip side, interpersonal intelligence is the ability to interpret and respond to the emotions and motivations of others, crucial for successful communication and relationship building. Both types play a significant role in our daily interactions and are influenced by cultural and social dynamics, providing different cultures with unique lenses through which to view personal intelligence. Cultural influences on personal intelligence. Every culture has its distinct take on personal intelligence, influenced by its history, symbols, and values. For instance, Western cultures often emphasize individuality and self-actualization as key aspects of personal development. In contrast, collectivist societies might prioritize conformity and group harmony, affecting how personal intelligence is expressed. These cultural perspectives shape the development of personal identity, guiding individuals on how they perceive themselves and relate to others. These variations raise intriguing questions about the universality of personal intelligence and highlight the role of culture in shaping human cognition and behavior. The journey of personal development. Personal development is a journey that begins early in life, with the infant-caregiver bond setting the foundation for future understanding of self and others. As children grow, they develop the ability to understand complex emotions and social roles, gradually shaping their personal identities. This process continues into adolescence, where the integration of personal desires and societal expectations takes place. Each life stage brings new challenges and insights, influenced by cultural contexts that alter the balance between personal and communal understanding. The path to mature selfhood involves recognizing opportunities and challenges as framed by one's cultural backdrop. Cultural variations in personal growth. Different cultures offer unique perspectives on personal growth and identity. For example, Balinese society places great importance on societal roles, emphasizing duty and responsibility. Meanwhile, Javanese culture explores inner-outer dichotomies, reflecting their approach to public and private personas. Moroccan traditions highlight the distinctions between public and private life. These cultural nuances impact how individuals perceive themselves and their connection to the community. Each culture provides a distinct balance of intrapersonal and interpersonal knowledge, showcasing the diverse expressions of personal intelligence influenced by historical and cultural circumstances. Biological roots of personal intelligence. Biology plays a fundamental role in the development of personal intelligence by providing the necessary framework for self-awareness and social interaction. Our inherent social nature and prolonged development as primates contribute significantly to our ability to understand both ourselves and others. This biological basis forms a foundation upon which cultural and historical influences build, resulting in diverse expressions of personal intelligence. This intersection of biology and culture creates a complex tapestry of individual differences, emphasizing that personal intelligence is both a biological phenomenon and a cultural artifact. Western focus on individuality. Western cultures tend to focus on individuality and self-actualization, often seeing the self as an entity to be cultivated and expressed. This emphasis shapes the development of personal intelligence by highlighting inner development and self-expression over collective identity. This cultural stance, however, is not a universal human experience, but rather a choice influenced by historical and cultural contexts. It raises intriguing questions about the extent to which personal intelligence is a developmental imperative or a social construct, shaped and sometimes limited by cultural biases prevalent in Western societies. Critiques and challenges. Although personal intelligence is an engaging subject, it faces critiques concerning its scientific validity and complexity. Critics argue that the culturally dependent nature of personal intelligence makes it difficult to categorize alongside other recognized forms of intelligence. These challenges prompt further exploration into how personal intelligence corresponds with established cognitive frameworks. The juxtaposition of universal features with cultural nuances suggests a layered complexity. These inquiries encourage a deeper evaluation of personal intelligence, pushing students of cognition to consider its scientific robustness and potential influence across different domains of intelligence. The interplay of culture and identity. Cultures play a significant role in determining how personal intelligences develop and are expressed. Each culture confronts a choice in selecting the primary unit of analysis, whether it be the individual self, the nuclear family, or a larger community entity. This selection influences individual perceptions of self and others, providing different interpretive contexts for personal experiences. Cultural interpretations contribute to the development of a second-order capacity, which modulates other forms of intelligence. Understanding this interplay of cultural and personal factors enriches our comprehension of personal intelligences and underscores their importance in human cognition. The theory of multiple intelligences posits that human intelligence is not a singular trait, but a diverse set of capabilities. It identifies several intelligences, such as linguistic, musical, and spatial, each with its distinct computational core. Every individual exhibits varying degrees of these intelligences based on hereditary factors, early learning experiences, and environmental influences. This understanding challenges the traditional view that equates intelligence with a narrow range of linguistic and logical abilities, expanding it to include a broader array of human potentialities. The theory suggests that while individuals may exhibit strengths in certain intelligences due to environment or innate tendencies, everyone can develop each intelligence to some extent. This perspective redefines intelligence from a fixed trait to a dynamic range of capabilities that can be fostered and developed over time. It also emphasizes the interaction between these intelligences as they combine and build upon each other throughout a person's life, playing significant roles in societal functions and personal growth. The theory encourages educators to nurture all types of intelligence, fostering a more inclusive approach to teaching and learning. Critiquing the theory. While the theory of multiple intelligences offers a broad viewpoint, its critics argue that there are significant gaps and oversights. The theory may appear eclectic or overly broad, lacking precise definitions for each intelligence. Critics suggest that it doesn't adequately address how these intelligences interact or the potential for overlapping capabilities. Additionally, some argue that the theory might ignore key areas of human cognition, like emotional intelligence or social skills, which are also crucial to personal and professional success. Another critique hinges on its practical application. How can educators and policymakers seamlessly integrate this theory into educational systems designed around traditional intelligence metrics? Furthermore, while the metaphor of computational cores for each intelligence is intended to be illustrative, it falls short of accurately reflecting the intricacies of human brain function. By comparing intelligences to computer-like systems, the theory risks oversimplifying the rich complexity of human cognition. Despite these criticisms, the novel approach stimulates ongoing dialogues about diversifying educational strategies to accommodate varied learning styles, driving educational reforms focused on developing all-around abilities in students. Related theories and historical context. The idea of multiple facets of intelligence isn't entirely new. Historical concepts such as faculty psychology from the 19th century, which recognized separate mental faculties, paved the way for modern theories. However, faculty psychology eventually lost favor due to emerging scientific approaches that sought universal psychological laws. Despite this, theories advocating for modular views of the mind have resurfaced, illustrating a renewed interest in specialized cognitive functions. British psychologist D. Alan Allport's depiction of the mind as comprising independent production systems aligns closely with this notion. His model details various cognitive operations that occur parallelly, aligning with the idea of multiple intelligences. Philosopher Jerry Fodor also argued for mental processes as encapsulated modules, each functioning independently. This perspective matches many core aspects of the multiple intelligences theory, suggesting that the brain organizes knowledge into distinct domains. Though these modular views often exclude a central processing system, which some argue is necessary for integrating information from different modules, they align well with observations of cognitive specialization. Together, these theories provide a robust foundation for understanding cognitive diversity, echoing the long-standing debate on how best to measure and define intelligence. Implications for education and practice. The theory of multiple intelligences has significant implications for education and practical applications. It urges educators to expand their teaching strategies beyond traditional verbal and mathematical focus, fostering environments that allow various intelligences to flourish. In practice, schools could integrate music, arts, physical education, and interpersonal activities into the curriculum, recognizing each as a vital area of student development. This inclusive approach not only acknowledges diverse talents, but also bridges the gap between educational and real-world skills. In an educational setting, addressing multiple intelligences can personalize learning experiences, making them more engaging and effective. Teachers can use diverse methods and resources, such as project-based learning and experiential activities, to cater to different learning styles and strengths. Recognizing students' unique strengths and fostering them can lead to improved motivation, self-esteem, and mastery of subjects. Furthermore, this perspective encourages learners to pursue their natural interests and talents, contributing to their personal and professional satisfaction. By applying this theory, educators and policymakers can create more equitable and effective educational systems, ensuring all students have the opportunity to succeed and excel in their unique capacities. Unaddressed psychological constructs. The theory of multiple intelligences, while broad, does not encompass all psychological constructs. Key areas like social psychology, temperament, character development, and emotional intelligence remain outside its scope. This omission is partly due to the theory's focus on distinct cognitive abilities rather than emotional or social skills, which are equally pivotal in human development. However, it intersects with these domains by highlighting the cognitive elements involved in human interaction, aesthetic appreciation, and physical activities, fields often overlooked in traditional intelligence assessments. The inclusion of interpersonal and intrapersonal intelligences provides room for acknowledging emotional and personality factors, increasingly seen as crucial to life success. However, broader aspects of motivation and attention also escape exhaustive treatment within this theory. Though motivation and attention are foundational to nurturing intelligences, they remain peripheral in its framework. These limitations suggest that while multiple intelligence theory offers a valuable paradigm shift, it should be supplemented with other psychological theories to present a comprehensive picture of human capabilities. The challenge lies in integrating various psychological dimensions cohesively to address individual differences comprehensively. Higher-level cognitive functions. When exploring cognitive abilities, higher-level functions like common sense, originality, and wisdom present challenges for the multiple intelligences framework. These qualities transcend single-domain definitions. For instance, common sense often reflects effective interpersonal skills and practical applications, not just intellectual prowess. Originality involves generating new ideas requiring mastery in a domain, while genius involves cross-domain connections and metaphoric thinking. The ability to create metaphors and find analogies challenges the separate intelligence concept, pointing instead to broader integrative abilities. The theory struggles to encompass wisdom, which transcends specific intelligences, involving synthesis and judgment across life experiences. This synthesis suggests a confluence of intelligence with personality and experience. While some argue for the existence of a central processing ability that integrates module inputs into cohesive actions, others see higher level skills as extreme expressions within domains. Overall, these high order operations pose questions on whether the theory should account for more general cognitive processes. Rather than considering them exceptions, integrating such functions could enhance understanding of how diverse intelligences converge into complex cognitive capabilities important for everyday life and success. The sense of self and intelligence. The concept of the self complicates the theory of multiple intelligences, presenting as both a central and emergent capacity. This sense of self, deeply interconnected with intrapersonal and interpersonal intelligences, grows with cultural context and personal experience. In modern societies, the self translates into a decision-making agent, reflecting a balance between personal introspection and societal integration. This dual role complicates the simplistic separation of intelligences into distinct capacities. Some suggest the self might be an eighth intelligence, encapsulating and regulating others, seeing the self as a central processor in cognitive frameworks. Others propose viewing the sense of self as a developmental achievement, emerging from multiple intelligences working harmoniously. This viewpoint recognizes the cultural and symbolic contexts needed for self-conception, demonstrating how our sociocultural environment shapes self-awareness and identity. By combining cognitive competencies with cultural narratives, individuals craft self-models reflecting their identities. This synthesis shows the overlap of intellect and culture, suggesting that the sense of self results from the interplay of intelligences with cultural symbols, framing individuality within a broader social and intellectual context. Potential challenges to the theory. Despite its innovative approach, the theory of multiple intelligences faces challenges that could disprove or necessitate revising its framework. If significant human intellectual activities remain unexplained by the theory, or can be better rationalized through alternative models, its validity may be in question. Further neuroscientific or cross-cultural research might reveal differing cognitive processes, prompting reevaluation of current understandings. Traditional concepts like comprehensive neurological or psychological systems might offer superior insights. Additionally, critiques emphasize the limited empirical support for some intelligences, suggesting refinements or exclusions for specific capabilities currently listed under the theory. The pressure also exists to recognize universal or shared cognitive processes, like memory and learning, that interact with intelligence domains. Although accustomed to theoretical refinements, any fundamental flaw or superior competing theory could lead to substantial reconsideration or rejection of the model. Nevertheless, such scrutiny is crucial, ensuring robust and adaptive theoretical frameworks that evolve with advancing knowledge and methodologies, but remain grounded in practical and scientific reality. Broadening empirical research and integrating additional psychological insights could further solidify the theory's application and relevance in understanding diverse human abilities. Conclusion: bridging intelligence and culture. Reflecting on human intelligence, it's clear that intelligences can't be isolated from meaning and culture. The world offers rich contexts for intelligences to express and develop, transforming raw capacities into tools for personal and societal evolution. Multiple intelligences allow us to navigate symbolic worlds and partake in complex cultural practices. By participating in interpretation-heavy environments, we further enrich our intellectual potential and create dynamic knowledge systems. This narrative underscores the importance of understanding how social interactions and cultural practices shape intelligence. Beyond computational models and analytical abstractions, intelligence embodies experiences, symbolism, and cultural constructs. These elements are pivotal for integrating theory into educational practice. It advocates for holistic educational approaches that foster diverse intelligences, nurturing students as whole individuals within their cultural narrative. Intelligence isn't merely processing information. It's about meaningful engagement in a world dense with symbols and cultural significance. Emphasizing this interplay between culture and cognition Future educational practices should aim to cultivate all aspects of intelligence, aligning them with evolving cultural contexts, paving the way for individuals to contribute meaningfully to their communities. Moving towards educational applications. Transitioning to practical applications, the theory of multiple intelligences demands rethinking educational practices. Key to this is reshaping curricula to encompass diverse cognitive abilities, ensuring holistic development. Moving away from conventional focus on linguistic and mathematical skills, more inclusive frameworks recognize and nurture varied intelligences. This means integrating arts, music, physical activities, and interpersonal interactions to enrich learning. Such diversity prepares students for a wide range of real-world roles, honoring individual strengths. Educational institutions stand to benefit from personalized teaching methods that support different learning styles, engaging students through customized teaching strategies that reflect their unique capabilities. Providing different pathways allows learners to flourish across domains, enhancing motivation and educational outcomes. Teachers play a central role in identifying students' dominant intelligences, tailoring instruction to inspire curiosity and passion. Additionally, fostering innovative thinking and problem-solving lies at the intersection of these varied intelligences, sparking creativity and holistic understanding. Through these changes, education becomes not just an acquisition of knowledge, but a journey to empowering individuals who can thrive in a multifaceted world of work, relationships, and creative endeavors. Symbols serve as a crucial link between our biological predispositions and cultural frameworks. Biology sets the potential for cognitive activities through the neural structures and synaptic connections, whereas anthropology explores the varied cultural roles and thought processes developed over time. However, these disciplines speak different languages, with biology focusing on brain structures and anthropology on societal functions, creating a gap. Symbols step in to bridge this divide, functioning as common elements that both our nervous system and cultures can engage with. They allow for a shared understanding, helping translate biological capabilities into culturally relevant concepts, such as language and mathematics. The broad spectrum of symbols. Symbols are not just confined to words or numbers. They span a diverse range of elements like pictures, gestures, and mathematical notations. A symbol can represent tangible or abstract ideas, adapting meaning based on community interpretation. For instance, a painting might evoke emotions beyond its physical colors. This adaptability allows symbols to express varied meanings, from simple narratives to complex scientific theories. Symbols are building blocks for understanding that transcend biological limits, as our brain is wired to learn from these symbolic entities. They facilitate communication and cultural continuity by embodying universally understandable concepts, essential for social interaction and intellectual growth. Symbolic development, a childhood journey. Symbolic competence begins unfolding in childhood through 4 distinct phases. Infants initially grasp basic understandings, connecting activities with meaningful outcomes. By early childhood, rapid development sees children engaging with various symbol systems, language, art, music, and dance. They build foundational knowledge, supported by dual aspects of development, waves and streams. As they grow, school-aged children refine these skills, learning complex cultural symbols and notational systems, crucial for cultural participation. By adulthood, individuals are prepared to share symbolic knowledge, contributing to cultural advancement. This developmental journey underscores the importance of nurturing symbolic capabilities from a young age. Interacting intelligences in symbolic growth. Human intelligence encompasses various domains which interact during the symbolic development process. In infancy, multiple cognitive skills, such as spatial, musical, and logical mathematical, start emerging independently while gradually influencing each other. For instance, understanding spatial relationships enhances fine motor skills, vital for intricate tasks like drawing. Symbolic activities in children, like storytelling and pretend play, synthesize these diverse intelligences, forming a cohesive cognitive foundation. This interplay of intelligences highlights the dynamic and interconnected nature of human cognition, which is enriched through engagement with symbols. It reflects the brain's remarkable adaptability, leveraging multiple competencies to decode and create meaning. Streams and waves, pathways and symbolization. Symbolic development follows two primary pathways, streams and waves. Each symbolic system, like language or music, progresses along a distinct stream. In language, syntactic abilities grow from single words to complex sentences. However, symbolic learning also involves waves, psychological processes that spread across domains. Take event structuring. It appears in language as well as in play and art, linking symbols to real-world actions and roles. These overlapping waves reveal our flexibility in applying similar cognitive strategies across varying contexts, demonstrating humanity's innate capacity for broad symbolic thinking. They illustrate how symbolic skills aren't confined but evolve across different realms. Channels, formal symbolic learning. Around 5 years of age, children embark on mastering notational symbolization, utilizing systems that organize and convey complex information. This learning occurs through cultural channels, formal systems like literacy and numeracy familiar in education. Notations are second-order symbols, such as writing that represents spoken words. Cultures provide these channels, which shape cognitive development. Mastery of these systems becomes a core educational focus, marking a shift from informal to structured learning. The child's world becomes more literal-minded, focusing on correctness and conventionality. This stage is crucial, though it may temper creativity, honing skills vital for cultural participation and intellectual discourse. The role of education in symbolic mastery. Formal education plays a pivotal role in facilitating the transition from basic symbolic competence to advanced mastery. By structuring learning environments around diverse symbolic systems, education aims to align individual intellectual capacities with cultural expectations. As children grow, educational settings introduce them to notational systems, embedding essential skills for societal roles. This process often stifles the free-spirited creativity seen in younger years, but provides the foundation for standard cultural participation. The educational journey bridges individual potential with societal demands, ensuring a cohesive intellectual environment where individuals can thrive and contribute meaningfully to their communities. Cultural impact on symbolic development. Culture profoundly influences how symbols are interpreted and utilized, shaping intellectual development and expression. Each culture offers unique symbolic systems, from language and art to traditions and rituals, guiding individuals in mastering relevant skills. Cultural values dictate which symbol systems are emphasized, directing educational focus and personal growth. These symbolic frameworks are vital for forming social cohesion and identity, embedding shared meanings and practices within communities. Understanding the cultural context of symbol use helps appreciate the diversity in human cognition and the varying pathways individuals follow to achieve competence across different symbolic domains. Controversies in symbolic learning. The journey of symbolic development invites debates on its underlying processes. Scholars contest both the rigidity and flexibility of learning stages, questioning if cognitive growth strictly follows age-related milestones. Other perspectives argue for dynamic learning, where abilities evolve based on environment and cultural experience. The scope of potential symbolic systems and the impact of early intervention also trigger discussions. While some emphasize genetic predispositions, others highlight environmental influences, advocating that consistent training can significantly shape cognitive outcomes. These controversies underscore the complexity of symbolic development, navigating between innate potential and cultural shaping forces. The future of symbolic competence. Exploring symbolic development prompts questions about the future of human intelligence in evolving cultures. As societies progress technologically and culturally, new symbolic systems may emerge, reshaping cognitive expectations. The interaction between biology and culture remains central, potentially leading to novel educational approaches to nurture emerging intelligences. Understanding how intrinsic capabilities synthesize with cultural elements could revolutionize learning frameworks, prioritizing adaptive skill sets. Ensuring that symbolic education remains inclusive and dynamic will help cultivate a society where everyone can harness their full cognitive potential, preparing individuals to navigate and contribute to the ever-changing global landscape. Education of intelligences spans various cultures, highlighting uniquely developed skills. The Puluwat Island youth, for example, learns navigation by harnessing spatial intelligence intricacies essential for survival in the vast Pacific. Meanwhile, the Quranic student in a traditional religious setting acquires linguistic intelligence through rote memorization of sacred texts. These distinct educational traditions paint a picture rich in diverse competences shaped by environmental and cultural needs. Through these examples, it becomes evident that cultural contexts significantly influence the development of specific intelligences, reflecting the value a society places on particular skills essential for its continuity. From individual learning to societal functioning. Education not only develops individuals, but also ensures they adapt effectively within their societies. This dual focus considers both personal development and societal needs. Through various modes, like the memorization techniques used by Islamic scholars or the kinesthetic learning of Puluwat sailors, individuals gain competencies that align with cultural values. Education becomes a tool for passing on traditions while preparing individuals to contribute meaningfully. As societies evolve, they face the challenge of balancing these traditional methods with modern approaches, often stirring debates about the effectiveness of fostering personal growth versus societal utility. Education, a societal imperative? In every culture, education plays a pivotal role. From Jules Henry reminding us of Homo sapiens as status seekers, to the methods used in traditional and modern educational settings, education is crucial for socialization and survival. The importance placed on transmitting knowledge ensures individuals are prepared to engage productively with their environments. Whether through community-driven methods like bush schools or formalized systems like guild apprenticeships, each society develops unique methods closely tied to its cultural fabric. Education, therefore, becomes not just a tool for individual enhancement, but also a societal necessity, forging community coherence. Transition from traditional to modern schooling. As societies advance, their educational systems undergo transformations, moving from direct, unmediated methods to more formal schooling. Historical transitions include the initiation rites and bush schools of traditional societies, which gradually evolved into structured modern schools focused on literacy and scientific methodology. This shift reflects changing societal needs, emphasizing literacies and logical thinking over interpersonal and bodily intelligences. Such changes underscore the growing importance placed on critical thinking and adaptability in an increasingly complex world. However, this evolution also raises concerns about the potential loss of valued traditional skills and approaches. Quranic education, mastery through memorization. In the Islamic world, education often begins with Quranic schooling, where young students memorize the entire Quran, emphasizing phonetic recitation often without comprehension. This rigorous practice is designed to foster deep linguistic mastery and discipline. While arithmetic or logic may feature in some contexts, primary focus remains on religious texts, shaping students' cognitive development around linguistic intelligence. Such educational traditions illuminate the interplay between cultural heritage and learning styles, presenting a stark contrast to modern Western educational paradigms focused on critical analysis and conceptual understanding rather than memorization. The evolution of secular schooling. Modern secular schools represent a departure from religiously influenced educational systems. These institutions embrace a broader curriculum, integrating knowledge across sciences, mathematics, and arts, devoid of a singular religious focus. Shifts from clerical instruction to state-employed teaching professionals emphasize intellectual credentials over moral standing. While maintaining some traditional schooling features, secular schools prioritize skills like abstract reasoning, logic, and personal development. This evolution, while expanding academic focus, also cultivates greater individual agency, as students navigate their learning paths, choosing specializations that align with personal goals and societal expectations. Challenges and critiques of modern schooling. Modern secular education has faced critical examination, with scholars questioning its influence and effectiveness. Critics argue that it often prioritizes certain intellects, logical, mathematical, over artistic or interpersonal skills, sometimes at the expense of holistic development. Concerns also surface about the schooling system's alignment with socioeconomic issues, where equal opportunities can remain elusive. Despite criticism, studies show well-structured schools positively impact students' lives, offering pathways to success. These debates highlight the ongoing need to reassess educational models, ensuring they nurture diverse talents while preparing individuals to thrive in complex modern societies. Literacy beyond the basics. Literacy is more than just reading and writing. It alters thought processes, enhancing abstract thinking and symbolic reasoning. In literate societies, individuals navigate language and information with a precision unknown in oral cultures. Literacy opens channels for indirect communication and new relationships, fostering self-understanding and broad social interactions. However, literacy's transformative power is tempered by how it integrates with schooling. The Sino-Liberian study by Michael Cole and colleagues reveals that even high literacy levels don't automatically produce broader cognitive shifts. Rather, it's literacy within educational frameworks that catalyzes deeper changes. Science, the new frontier? Science fundamentally reshapes ways of thinking by combining empirical data collection with theoretical frameworks. This mode of reasoning, distinct from mythological or spiritual explanations, remains open to adaptation in light of new evidence. However, the transition to a scientific mindset is not without challenges or resistance, as seen throughout history. Science emphasizes a willing shift to logic and observation, enriching human understanding in unprecedented ways. Intellectual agility is required, yet this modern embodiment of intelligence still relies on utilizing traditional cognitive faculties in novel, systematic manners. Balancing tradition and modernity. As educational systems worldwide evolve, the challenge emerges to balance preserving traditional skills with embracing modern educational advancements. The transition from traditional learning forms, like the personalized knowledge of artists or navigators, to standardized schooling involves trade-offs, potentially sidelining vital cultural skills. Each intelligence form, whether bodily, spatial, or interpersonal, retains value, contributing to a holistic understanding of human capabilities. Moving forward, societies face the task of innovating educational practices that celebrate and cultivate diverse intelligences, while also preparing individuals for dynamically evolving global realities. The Suzuki method, emerging from the Talent Education Center in Japan, highlights the potential of young children under its structured musical regime. This education model emphasizes the natural capacity of children to learn through imitation and repetition, akin to acquiring language skills. With active parental involvement, notably by mothers, children as young as 3 achieve exceptional proficiency in the violin. The program's success underscores the blend of genetic and environmental factors in nurturing talent. Yet, it opens a dialogue about focusing narrowly on specific skill sets might limit exposure to broader educational experiences. The Suzuki method's integration with Japanese cultural values has proven beneficial but raises questions about the adaptability of such focused methods across diverse cultural contexts. Linking education to economic and human development. A powerful narrative unfolds, connecting education with economic growth and societal advancement. In a 1980 speech, World Bank President Robert S. McNamara highlighted the equivalency of human development in driving economic progress alongside capital investment. Global discussions involving institutions such as the Club of Rome advocate innovative learning solutions that cater to unique contextual needs. Examples from countries like Venezuela underscore how educational reforms can tap into human intelligence's universal potential. While these programs often aim to cultivate specific skills, they reveal the challenge of balancing innovation with respecting cultural specificities. The narrative underlines the integral role of education, not just in fostering skill, but in shaping economically and socially progressive societies. Understanding the complexities of language evolution, the document delves into the fascinating world of language acquisition and its cognitive underpinnings. Studies highlighting the significance of the brain's left hemisphere in males, the adaptive nature of language processing in aphasics, and the resilient language development seen in deaf children spotlight the brain's remarkable flexibility and evolution. Contributions from pioneers like Chomsky and Gardner enrich our understanding of language's emergence and cognitive adaptability following brain damage. These explorations illustrate a deep intertwining of language with cognitive development, suggesting that our ability to communicate evolves alongside varied cognitive faculties, further indicating the importance of this in educational strategies. Diverse intelligences, a mosaic of human capabilities. The concept of multiple intelligences reveals a mosaic of human capabilities awaiting cultivation through education. Individuals possess various intellectual strengths, including spatial, musical, and logical mathematical abilities. Psychology and cognitive science provide insights into the unique prowess observed in mathematical savants and cross-cultural phenomena, such as the spatial expertise of the Eskimos. Understanding these diverse modes of intelligence encourages a more tailored educational approach that respects and harnesses each individual's distinct abilities. It invites educators to craft learning experiences that are not only cognitively aligned, but also culturally sensitive, broadening our view of educational success beyond traditional metrics. The interplay between brain function and arts. Artistic capabilities bridge cognitive science and creativity, shedding light on the brain's resiliency and adaptability. Studies reveal how brain damage can uniquely impact faculties like musical ability, yet allow certain creative skills to remain intact. This interplay tells a story of the brain's capacity to adapt, offering promise for nurture-based creative development in educational settings. By examining cognitive processes associated with artistic talents, the text suggests integrating art into education can foster varied intelligences and develop holistic thinking. These insights emphasize the art's power in forming critical thinking skills and allowing for profound personal growth within educational paradigms. Revisiting early education models. Persistent critiques of traditional education highlight the need to adapt models in alignment with understanding cognitive diversity. The document underscores the influence of culture in shaping learning methods and intelligence. Global examples, from Freire's literacy campaigns to Sesame Street, illustrate the necessity of aligning education with cultural and motivational contexts. This includes reassessing schooling structures to support multiple intelligences, moving beyond one-size-fits-all systems. A shift towards personalized, culturally compatible educational strategies can better nourish individual potential, fostering a learning environment conducive to diverse intellectual and creative expressions. This approach seeks to redefine educational success to embrace holistic human development. Harnessing the power of technologies in learning. Technology's potential in education is vast, presenting opportunities to model cognition and personalize learning experiences. The text stresses computers' role in supporting varied educational methodologies by adapting to different intellectual strengths and preferred learning styles. This technology-driven approach can offer engaging, tailored educational experiences while respecting cultural nuances. Although the implementation of technology must remain culturally sensitive, its strategic use can empower students with interactive learning opportunities and expand the horizons of how intelligence is cultivated and assessed. Interwoven with intelligence theory, such approaches encourage broader thinking on human potential. The role of kinesthetic intelligence in learning. Bodily-Kinesthetic Intelligence finds new relevance as the text explores its impact on learning and cognitive development. The intricate link between physical expression, such as dance, and cognitive processes is examined through evolutionary perspectives, underscoring how movement can enhance brain growth and coordination. Educational methodologies leveraging kinesthetic learning can facilitate deeper engagement and retention, benefiting students who thrive through physical interaction. These insights call for an educational transformation that recognizes the significance of active learning styles, empowering educators to incorporate kinesthetic approaches into the curriculum, expanding traditional teaching paradigms to accommodate diverse learning needs. Cultural narratives and educational diversity. Educational diversity emerges as a vital theme, with culture serving as both a foundation and a catalyst for learning. By exploring diverse educational practices like the Japanese and Quranic systems, the narrative offers a glimpse into how culture can influence educational approaches. This examination highlights how reaching out to students' cultural backgrounds enhances learning outcomes, offering a platform where traditional and modern educational practices meet to foster comprehensive cognitive development. Emphasis on cultural narratives underscores education's role in respecting and celebrating diversity, promoting an inclusive approach that values varied educational heritages and contributes to a more understanding society. Critiques and future directions in education. Echoing globally shared criticisms, the text challenges conventional schooling models, advocating adaptation to cognitive diversity and contemporary needs. Embracing multiple intelligences over rigid IQ metrics suggests an educational shift toward a more holistic assessment of potential. By integrating these perspectives into curricula, schools can better nurture diverse talent and creativity, ultimately fostering a broader understanding of intelligence. The exploration of educational methodologies illustrates a move towards personalized learning experiences, shaping an educational future that is inclusive, innovation-driven, and attuned to the rich array of human capabilities, heralding a new era in educational thoughtfulness.